Yes, thank you very much. So I think most of the people which are here know me. So I'm Jan Peter. I worked as a postdoc in Terravere. And today I would like to talk a little bit about EO Browser, which is a new tool which is thought to bring remote sensing data, I think, to a wider public. My original plan was a little bit different because I wanted to show some live animations, but then it turned out that my current, because I'm in Finland at the moment and my current network here does not support big blue button live sharing. So in the last 15 minutes I had to like make screenshots from everything I wanted to show and put in my presentation. So I'm very sorry for this. I think this live animation would have been much better for demonstration purposes. Yeah, but I hope the best that you will get some information. Okay. Well, I don't know how many of you have already worked with EO Browser. Probably some. So EO Browser is was produced by a Slovenian company which is called Synergize, and the idea was to put as many satellite archives in a user-friendly graphical user interface, so that you can manipulate the data in the way you want. Okay. So having said this, it's allowing calculation of some vegetation indices. You can create some time series and export them as CSVs. You can also create some nice animations. I will show you how this works, like sliding windows and also some time lapses. But of course, it comes at the cost of analysis flexibility, where we as scientists are usually interested in. Yeah. Nevertheless, it's a good tool, even for scientists sometimes. For instance, when I want to have a quick overview of how many cloud-free images for a specific region I have, this is much easier to do in EO Browser compared to other platforms, for instance. Okay. Yeah. So everybody can register. You just have to register with your name and a password via this internet address here. And then once you're logged in, it will somehow look like this. So in the upper right corner here, you can like search for specific regions you're interested in. So usually when you type in here, for instance, Terravere or whatever, it will get you directly to the observatory. And on the left side, there's the panel where you select the dates, you select the vegetation index, and also the Sentinel platform that you want to look at. Yes. So for whom is it? I said this already. Well, it's scientist, as a scientist you can use it, but you have to be aware that it comes at reduced flexibility when you want to manipulate and analyze your data. Well, for students, if you start with remote sensing, it's definitely a good idea to have a look at EO Browser. And I think it's made for interested citizens that want to get acquainted somehow to remote sensing. This is what it is, I think. Yeah. Well, and I will show you in the next slides the basic usage. As I said, it's very intuitive to use. So I think everybody would have also managed without this presentation to use it. You can quickly check data availability. That's what I often do. You can browse around. That's why it's called browser, just for interest. Well, if it comes to more complicated tasks, such as classifications or whatever, well, I will show you that it's possible to use customized Python scripts. Probably not for every purpose, but if you're a Python programmer, or at least you know how to write a code in Python, then you can use this in EO Browser as well. I will show you an example a little bit later. Yeah, so I will show about the general usage. Then I prepare, because they're like predefined themes in EO Browser, and I will show you one for wildfire. And then you can analyze nicely time series for specific regions. Well, I did this for Nigula LKA, which is a nice peatbog in Estonia. because this was exposed to drought in the last years. So that's one way to use EO browser. Well, then there's sliders, time lapses, downloading Python scripts. Some of them I will cover. Some of them, unfortunately, I cannot because I just hadn't enough time now to switch from the live presentation to the PowerPoint presentation mode. But yeah, let's see how far we can get here. Yeah. And if you have any questions, or if you recognize that my sound becomes noise, just let me know, because there's construction work going on in this building. It's very annoying, at least for me. I hope that you don't get too much of this noise. Maybe just maybe somebody could just write a short message in the chat so that I know that the sound is okay, and it's not too disturbing. Well, yeah, this is how it looks like. So here on the left, you can select from the satellite archive that you want to use. You can see there are quite many of them already accommodated. So I work at the moment mostly with Sentinel-1, 2, and 3, and all of them are accommodated here. So even Sentinel-1, that's quite nice. So once you have selected one of these satellite archives, you go to search, and then you have to select a specific date or a date range. Before you have done that, you're not able to go here to visualize. So you can only visualize once you have selected an archive and a date range. Okay, and then you go to visualize, and then you can select between different indices that you want to calculate. You can also, what I did here, you can, when you go to this button here, you can also upload shapefiles. So this is here, for instance, so I created a shapefile for Nigula LKA before, and you can upload this shapefile and then calculate indices, which are then somehow give you an average only over this polygon here. This is also quite nice. Yeah, so this is exactly, so you select the archive, and then here you can select the date range, and then in the next step you can either choose a predefined vegetation index such as NDVI or whatever, but you can also create, you can simply drag and drop the bands of your respective satellite platform here in this formula equation and create an own index if you are interested. And you can also use an option which I show you a little bit later, where you could, it's called customize script. So you can put in a Python script, and then it calculates the Python script for this polygon here that you uploaded before. Yeah, then is one option. So let's say that you are interested in a specific remote sensing topic. Then you can here go to theme, opens this window, and here you can select between different options. So for instance, I selected here wildfires, and then you can go to a specific region where probably you know that a wildfire occurred. And then so here, for instance, you see this area here is an area in Sweden, middle Sweden, that was built in 2018 after a drought year. And when you go there and you have selected what the wildfires theme, then it gives you already some, I would say, more sophisticated indices, such as the burn area index, for instance, the burned area detection, or also the normalized burn ratio. So these indices you have usually when you use the default theme, they are not in there. When you use wildfire, they are already pre-calculated. So you can simply click on them, and then it will visualize this area with this specific band math here. Okay, so this is quite nice. So for instance, here I selected the normalized burn ratio, and then it will give you the same image, and then you can here see the burn severity, for instance. Okay. Yeah, so what I did, and for instance, I set this, so here's an option which is called custom script, and you simply copy and paste a Python script in this window here. So here I had a Python script from my own which I simply copy and pasted here as a small window. And I use this to visualize active fires where I exploited the shortwave infrared information a little bit more. So this is just this is a shortcut from the script. The whole script is a little bit longer, but you see, so when you compare, for instance, with the slide before, so here you can't see the active fires because this is here a regular true color image. But then when I put in my script and I click refresh eval script, then you see that I can much better see the ongoing fires here because I did a little bit of more coding work. So if you are more advanced, you want to, as a scientist, you are advanced in Python, and you want to put some more information than usually, then you simply can put in your Python script here and see what it does for you. So this is also quite a nice option. Yeah. So then what I wanted to show you is what is, let's say, as a scientist, want to write a project application. For instance, in monitoring or analyzing drought effects in peat bogs in the Baltic countries or whatever. So let's say 500K project application. Then very often it's quite nice if you can show already some preliminary results or some nice figures or whatever. So what you can do here is, for instance, here's the Nigula LKR. This is this area here. And I selected here the normalized difference moisture index, just to see whether the last years had any influence on the peat bog. Okay. Yeah. So I upload my shapefile for Nigula, which I have drawn before, and then you can go to this little button here. So you select the NDMI, and then you go to this little button here. And this will create you some time series. And this looks like this. So you can change, for instance, the maximum cloud cover that you want to have included. And then you can choose between different time intervals. You can calculate for 1 month, for up to 5 years back. When you choose 5 years, of course, it will take a little while until the time series has been produced. Okay. And this so this hasn't finished normally, because I hadn't time to wait until it has finished. Usually when it has finished, there will like a small button pop up here says export as CSV. So you can export this as a CSV file if you want to manipulate the graph or leave out some months. For instance, you want only the vegetation period or whatever, then you can manipulate this data set further in Excel, for instance. Okay. Yeah, then I think the last part of the presentation, and then we can probably discuss a little bit, is there are some options more. So here you see this, for instance, compare and pins. Okay, so once you have an image produced, like here, for instance, you can go to this one here, which says pin, and then it stores the image in some kind of a private repository which is connected to your account. And this looks like this. So here you see now I'm in the pins area, and here's everything which I have produced in the past and stored as pins is somehow here stored in my personal repository. So once you log out, because it's not saving. So EO browser is not saving sessions or whatever, but everything that you have pinned is automatically stored in this repository, and you can use it later on when you log in again. Okay. And then, for instance, if you want to compare the same area but for different time steps, you can go to this one here, compare. Then you will see once you press this one, a little number will pop up here. And what you can do then is, so for instance, I selected 2 different time points for one of the same area. Then I can, with sliding window, now you can't see it here, so the slider will be somewhere in the middle. So when you can slide this away, then you can compare in one and the same screen how the area has changed, for instance. So this is a very nice option for visualization. Okay. Yeah, and I think, yeah, this is basically what I wanted to show you. I think it would have taken more time when I would have done it live. So therefore, I finished a little bit earlier here. But yeah, let me know if you have any questions, or if you would like to discuss anything or whatever. Yeah, so that's everything from my side, from the presentation side.